Now starting. All attendees are in listen-only mode.
Good afternoon, everyone. My name is Jeffrey Jue, and thank you for joining UMass Extension's Landscape, Nursery, and Urban Forestry program and the Laboratory of Medical Zoology for TikTok with Tech Report Live webinar series. These webinars will be recorded and posted on our website. Our speaker for this webinar series is Dr. Stephen Rich, who is a professor of microbiology and director of University of Massachusetts Laboratory of Medical Zoology. Today, Dr. Rich will speak about ticks and personal protection. If you have any question during the webinar, please type it in the question box on your control panel, and Dr. Rich will answer the questions. After the webinar, there will be a short survey. Please complete the survey before exiting the webinar. Without further ado, here is Dr. Rich.
Thank you, Jeffrey. So hopefully that's working now. My screen is showing.
Yeah.
And I'm getting an echo. Is there a way to mute that echo?
I'll just mute myself.
Okay, thank you. Good afternoon, everyone. So this is a new media for me, doing a webinar. And so what I often do when I give talks in person, I'm hoping everyone can see my screen, but something I've become accustomed to recently is using this program called Mentimeter online, which allows me to query a little bit from the audience and to get some idea of how who all you are. A little bit about myself, but it's helpful for me to know the audience and know what's motivating you to spend the next hour listening to this webinar. So if you go to www.menti.com and enter the code 292855, which should be appearing on your screen, you can answer this series of questions that I'm going to pose to you. So I'd love it if people would log on to do that. I know if it's a challenge sometimes to have multiple windows open, but let's give that a shot. What I plan to do today is, as the answers are coming into these little responses, is I plan to tell you about what can be done to protect yourself and your perhaps your employees or your family from ticks and tick-borne diseases by measures you can take for protection against tick bites. And I'm going to present a model and use a couple of analogies that I hope are useful that allow us to understand or come to an understanding that ticks and tick-borne diseases, while they have unique challenges, they pose challenges which are similar to other problems that we deal with. And so I think being mindful of that can be somewhat empowering, in that we can see that things that we've used elsewhere can be successful here as well. So thank you for those of you that are contributing to this conversation. So a number of you are focusing on something that's very important, which is the disease aspects of tick bites. And we're certainly going to delve into that today and in greater detail when we talk about the pathogens in future webinars. So let me go to the next question. So these will be visible to you after I will post these with the talk, and you can see the kinds of things that people are concerned about today. All right, so my apologies. So here's the next question I have for you. So you've given me some ideas of the thoughts that come to your mind when you talk about ticks and tick-borne diseases. I'd also be curious to know a little bit about what your role is, or what your job is per se, whether you're a parent or you have a household and you're worried about your family, or whether you're working in the green industry, a landscaper, or a golf course superintendent, or a healthcare provider. All the different things are there, because I'd like to understand who you are as an audience and what kinds of things might be motivating you. And it may well be the case that you are multiple things on that list, and so that option is available to you as well. If you're a healthcare provider and a parent, you can enter both. So, and you can see this on your screen, so you can get some idea of who's joining us today. Few public health agents, school nurses. We think school nurses are an important part of the messaging system here, and of course parents and folks that are in harm's way in the green industry are all people that need to hear what we're going to talk about. One more question, and thank you for bearing with me. This is very helpful. Oops. A little clunky, let's see. I have one more question which really pertains to what your role is, whether you're interested in this primarily for your yourself or for someone that's that you employ, or so let me get to that next question. Sorry, this isn't clicking for me. All right, sorry, here's the last question. So is your principal concern about safety about yourself and your family, or are you responsible for the tick safety of others? So are you concerned about employees or people that are working for you or with you, or is this more about protecting yourself and or your family? And again, you may answer both of these are the result, but I'm curious to know about the sort of chain of command among the folks that are attending today. Great. So I see that a number of you have a responsibility for keeping other people safe. So that's great, because hopefully we can provide some information on how we get there. So let me now just go into the talk, having sort of got that input from you, which is valuable for today and for future webinars. So as I said, here's the title. I'm going to talk to you about ticks and personal protection. My name is Stephen Rich. I'm a professor of microbiology and the director of the Laboratory of Medical Zoology. I want to tell you just a little bit about the Laboratory of Medical Zoology first. We are a university laboratory. We're seated here at the University of Massachusetts. And the first thing for you to know about this is that it's a laboratory like other academic laboratories at this university and elsewhere, and that we have students, technicians, postdocs, faculty members, 3 faculty members that conduct research on tick-borne diseases, but also we do work on mosquito-borne diseases. We've done work on rabies in the past, and it's truly a well-rounded environment. Many of you may have heard of the Laboratory of Medical Zoology and or have heard of our one of our programs, which is Tick Report, which was started in the Laboratory of Medical Zoology in 2006. Tick Report is our the public service that we offer to people that want to have their ticks tested. I'll tell you a little bit about that at the end of today. I'll probably talk more in detail about that when we talk about the pathogens in future webinars and the way that we go about surveilling them. But it's important for you to know that the Laboratory of Medical Zoology sits in this in the university. It's a public service research laboratory, and you know, there's some really bright and hardworking folks that are in the laboratory, both generating original information that gets published as research papers, but also they're providing this service to folks that are seeking information about the ticks that bite them. So the outline of what I want to do today is I want to discuss tick protection in what I would call a public health approach, which may sound familiar to some of you, and other of you may say, well, I'm not sure exactly what we mean by this, so I thought it would be worth just talking a bit about this in general, and then digging down and talking about a couple of analogous examples that I think will underscore exactly the kind of thing I'm talking about. So at the start of a process of taking a public health approach to a problem like ticks and tick-borne diseases, we have what is clearly the kind of thing that's happening today, which is a learning process. Both learning from information that can be shared between groups. For example, groups like our laboratory can share information, but also just learning new information about tick behaviors or pathogens or types of things that can be used to control ticks. And that's an important fundamental first step, is just learning about what these risks are and and making some assessment of them. And I put here that a big important part of that is, among other things, assessing trade-offs. And what I mean by that is it's important to recognize that Lyme disease exists as a public health threat in the context of lots of other tick-borne disease threats. And so we can evaluate whether Lyme disease is the most important, whether it's equally important or less important than others. Other kinds of trade-offs we can talk about are, I'm going to tell you about ways to control ticks from biting yourself. Some of these involve chemistries, and there are people that are always concerned about the use of chemistries on their person or in their yard or whatever. And so again, through learning, we can sort of evaluate those trade-offs. Is the risk of using a chemical that has a pretty good safety profile, but maybe have some risk factors in certain groups, does that outweigh the risks associated with the ticks that you're trying to keep from biting you? So that's an important part of this evaluation process. Clearly, another aspect of the public health approach is to avoid the risks, to learn the information, to learn as much as we can about the problems that we face, and then to come up with a set of best practices that would help to avoid those risk factors or prevent those exposures. And we'll talk about the different types of avoidances and different types of practices that can be utilized to affect that. The other thing that's important to understand is that because avoidance is not always 100%, because occasionally, despite the best practices, things slip through and we are exposed to things that we're otherwise trying to protect ourselves from. It's important to understand both the qualitative and quantitative features of those exposures. If a tick is bitten at us, if we, despite our best efforts to keep the tick from biting us, it's important that we're able to evaluate that tick bite, to evaluate that exposure, and know important steps that can be taken thereafter. At the end of this public health process, as I've sort of written it out, we can talk about the treatment that is involved with people that have, been unfortunate enough to have been bitten by a tick. The evaluation of the tick bite has been, or the outcome of the tick bite has been such that they may have acquired disease. And then there's a whole range of treatment options. There are long-term and short-term repercussions of those diseases and exposures. What I want to say today, for the purposes of this talk and most of what I'll talk about in the webinar series, we won't address treatments. We won't address because it's not the purview of this kind of forum to discuss medical matters or how one would go about treating diseases. That's best left to physicians and to people and their healthcare providers. So I just want to set up that as sort of a parameter for how our conversations would go. Is that if we talk about we're focusing mostly on prevention of disease and the prevention of disease and or prevention of severe disease and the best ways of affecting those aims. Another thing that comes to mind when I do these kinds of talks is that there is a tremendous amount of good information out there. There's also some bad information. And for the most part, the way you can tell the good information is that if there's a consensus, this is a little bit of a generalization, but if you find things again and again in many different sources, it's usually because that information that's being provided has been evaluated in by a number of different constituencies, and so that information is quite reliable. One of the very good sources that I turn to for protection against ticks and management of ticks is this handbook, which is from the Connecticut Agricultural Experiment Station. It's written by Kirby Stafford and was published in print. It hasn't been out in print for a while, but it is available as a PDF. You can download it. It's 60 or so pages. It's just rich with information about tick biology and tick-borne diseases, and a lot of the information that you'll hear from me is consistent with what comes out of that book, and it's a great resource to have at the hand if you're trying to recall something about what I've said, or trying to understand something that wasn't covered in the webinar today. Another resource is the Tick Encounter Resource Center. So this is Dr. Tom Mather at the University of Rhode Island, who we partner with. When we started in 2000, Tick Report in 2006, where we started testing ticks, we realized that we wanted to educate the public as well as providing our research mission. And the thought of going out and creating a web resource was attractive until we looked at the Tick Encounter Resource Center and said, well, this has already been done, and Tom's done a great job, or Tom and his group, his team have done a wonderful job, so there's no sense duplicating that. So we often reference people to this wonderful resource, which is at tickencounter.org, housed at the University of Rhode Island. Again, a lot of consistent information with what you would see on in Dr. Stafford's handbook that I showed you in the previous slide. And in this case, if you like this kind of thing, it's clickable and you can sort of navigate your way through the different topics. So to sort of dig into this problem, which many of you are familiar with, and to sort of hopefully maybe get you in thinking about it in a new way, I just want to talk about disease transmission in general and sort of waking up some ideas. So disease transmission we usually think of as, in most contexts, in terms of anthropognosis. That is diseases that are transmitted from human to human. And I have a list of some of those diseases that are directly transmitted or transmitted via vector, for example, in the case of malaria. But what's interesting about these compared to other types of pathogen or Lyme disease is that these always move from between our species, that they don't involve other reservoir hosts. And Lyme disease is different in that sense. Let me use an example of something that we all encountered last, I think this was last November, at the end of November, shortly after Thanksgiving. I remember seeing it when I went out to the grocery store to buy some lettuce to make a Caesar salad, and I learned that there wasn't any romaine lettuce on the shelf. I went to another store and they didn't have romaine lettuce either, and then I learned that the romaine lettuce had been pulled from the shelves because of this outbreak of E. coli 0157, which is one of the pathogenic strains of E. coli. And the actions that the CDC and the state health agencies took was to pull the romaine off the shelves, and that's probably a good practice because it prevented more people from getting sick. What I'd like to propose, though, is that there's no reason to believe that 0157 E. coli wasn't present before this outbreak, and that the measures that people would take to prevent themselves from getting sick, like washing their lettuce, washing their fruits and vegetables, which we should do as a matter of course, may often avoid disease that's actually present, or avoid pathogens that are often present. So I think there's a lesson to be learned from these kinds of things, that some of these outbreak scenarios can be avoided with common practices. And so the notion that diseases emerge from nowhere is probably a wrong way to think about it. Probably in the case of this 0157 outbreak, it was that maybe the incidence was slightly higher than it had been in the past, but most likely the incidences of people getting sick were just attributable to someone having been not as cautious as they might have been about washing the fruits or washing the vegetables, or it could have also happened at a production facility. But it was basically about a breach of a practice that would usually keep this thing from being spread. And when that breach arose, then you had the emergence of disease. Another analogy to think about is something that we've thought about, and more as I've become an adult and when I was a child growing up back in the 70s, is diseases associated with sun exposure. We now know that going out and baking in the sun all day with unprotected can have detrimental effects associated with the proliferation of different types of cancers. We know that there's a range of different procedures that you can take to protect yourself. You can wear clothing that protects yourselves from the sun's rays. You can administer lotions that will that will serve as sunscreens or sunblocks. You can wear sunglasses to protect your eyes, as shown in the image here. The point is that when we're confronted with a very serious threat of a disease like skin cancer, rather than feeling paralyzed with fear, we've learned to adopt strategies that can minimize those risks. Which of those strategies they want to opt for. And another learning lesson here is that even technology can help to analyze these exposures after the case or after the exposures have occurred. So it turns out that even if you have not successfully avoided the sun's rays sufficiently to avoid proliferation of a skin cancer or whatever, that it's possible to evaluate the lesions that are occurred and to make appropriate responses after the fact. I think that's a fundamentally important aspect of this as well, to not feel paralyzed with fear of avoidance, and to know that even after the exposures have taken place, there's something that can be done about these kinds of things. And obviously, the reason I'm talking about this is that this is all very true for ticks and tick-borne diseases as well. The last analogy I'll use is to suggest that when we want to protect ourselves against public health threats, I think it's useful to think about layers of protection that one would have, going from, to use the analogy of a castle, if you have a moat around, I mean, the avoidance of enemies, the purpose of a moat is to avoid interactions with the enemies altogether, right? To avoid having those enemies come into your realm. And the walls of the castle serve as a backup to that moat. And inside the castle, there are features that are the keep, etc., that are meant to protect the inhabitants of the castle. And while there are soldiers inside ready to fight if any of those boundaries are breached, oftentimes it may not be necessary to use them if you've created the defenses in a way that prohibits their entry into the castle in the first place. And then once inside, it's important to remember that there are still things that can be done, that we need not be feel doomed that we can't do anything even when one layer has been breached, because there are multiple layers that we can have in place for our practices. So let's go and delve into the kinds of things that we can think about in terms of controlling ticks and tick-borne diseases. And where I'd like to start with this is something that's commonly discussed in various environments, which is the idea of reducing the source of the public health threat itself. So typically that refers to reducing the number of ticks present. And as a proxy for that, because sometimes it can be difficult to reduce ticks, people think, well, maybe one thing we could do is we could focus on reducing the number of hosts. So key species in that source reduction plan often is deer. So it is true that white-tailed deer are an important host of ticks. Ticks, particularly black-legged ticks, require deer to feed as adults. And we know that to a certain extent, where there are more deer, there are more ticks. And so possibly reducing the deer numbers or reducing the deer herds can be effective. I was actually part of a project that Maine Medical Center ran several years ago to reduce to eliminate deer from a small island, Monhegan Island off coastal Maine. And that effectively eliminated the Lyme disease problem by eliminating ticks, because there were no longer deer for the ticks to feed on. However, that's not to say that reducing the deer has the same effect as eliminating the deer. So in that Monhegan study, it was particularly easy to reduce the population. I think it was something in the neighborhood of 40 or 60 deer on an island that was a mile long and a half mile wide. That becomes a bigger challenge when you're talking about trying to, eliminate the deer from a larger island or eliminate them from a whole state. And it's not clear that reducing the numbers has the same effect as eliminating the numbers, because what we see is in certain habitats where the deer are very abundant, there are ticks, and other places where the deer are relatively rare, there's still plenty of ticks. And so it's not clear how many deer you would have to eliminate in order to really impact the problem. Nonetheless, this is often seen as an approach. The other mammals that are figured in this, or the other host populations that are often talked about, are the white-footed mice, which again are key players in things like the Lyme disease cycle. And so there's a particularly interesting project proposal by an investigator at MIT to actually manipulate the mouse in a way that it might not be infectious or might be refractory to infection with the causative agent of Lyme disease. Again, it's an interesting approach. It's not clear the ecological impacts, like how many of these mice would have to be out there, and what are the repercussions, and there are controversies around it. Nonetheless, they represent these source reduction approaches, represent some of the things that people have proposed as measures to reduce and protect ourselves from ticks. There are also measures that focus more directly on the ticks themselves rather than on the hosts. You can do things like perimeter sprays in yards. So this is, again, this idea of the moat and the castle. You can do things to protect ticks protect ourselves from ticks before we even come to a close encounter with them. So I noticed a number of people indicated that they were from the green industry, so landscapers may be familiar with the idea that you can do perimeter spraying of yards, and that this can reduce or create at least a barrier for ticks in yards. And there are also measures such as the tick tubes shown here, which are treated with a acaricide and can be utilized to reduce ticks in the properties by targeting ticks that are feeding on mammals. I'd direct you to the Kirby Stafford handbook to get more information about the details of these kinds of approaches and other landscape practices. So I mentioned at the beginning when I said that there are these diseases, there's a notion that we have about diseases basically as anthroponoses, that people give them to people. Lyme disease is a fundamentally different thing in that people don't give it to people, ticks give it to people, and the ticks don't even acquire it from the people as ticks might, or excuse me, as mosquitoes might acquire certain diseases like malaria. Lyme disease is very different. Lyme disease is said to be zoonotic, meaning that it's transmitted in wild populations, and then occasionally, or perhaps not so occasionally in some instances, it spills over into our populations. So the approach to controlling this kind of thing has to be fundamentally different, because anything that we do to this population of people down here in the lower left-hand corner is not going to impact directly the transmission cycles that takes place among the ticks and mice. So the notion of treating these guys is probably a good idea if you can have some impact. It's not clear the ecological impact as it stands. But I want to emphasize this because it's important to remember, for the most part, where we're talking about zoonotic diseases, that humans are dead ends, and so they don't, dead ends in the case of the disease, and that they don't contribute to this cycle. And so anything that's done to treat humans is not going to necessarily reduce the risk. For example, vaccination. And that's because Lyme disease is an ecological or even maybe considered an environmental risk. In some ways, it's more akin to lead poisoning than it is to measles, because it's acquired by things outside our species. And the things that drive the incidence of Lyme disease are the things that drive the complex ecologies that make for more ticks, more infected mice, and different environments. So in terms of assessing where risks are highest, one of the practices that can be utilized is we can look to landscape practices to look at things that can be done to best manicure our properties in a way that it will reduce the number of ticks. So this is an image I took directly from the Tick Encounter resource page. You can see the link down below, or the URL rather. And what you see here is that this sort of unmanicured leaf litter with disorganized piles of wood, that poses a great habitat for white-footed mice and ticks, and they can be plentiful and abundant there. Whereas on the right-hand side of the picture, you see a well-manicured lawn that's not so conducive to ticks. So it turns out that ticks have a great inability to modulate their own humidity. They don't do particularly well in dry habitats like our own households. And so when a tick is exposed in an environment like this, where it gets lots of sunlight, very little leaf litter for it to cover up on, the ticks don't do so well. And so this is a good way to keep ticks off the areas that we most like to occupy. And if we manicure our lawns in such a way that our actions or our activities are mostly constricted or restricted to these sites where we're more tick safe, then we'll do a lot to avoid tick bites. Here's just a little diagram. There are many of these on the web, and there's a lot of nice. I think there's a very nice interactive one in Tick Encounter sites, the Tick Encounter site rather, that shows the types of practices, and also Kirby Stafford goes into detail about this, the types of activities or the type of landscaping practices that can be utilized to keep ticks away from the areas where our children play, where we're living, where most of our activities are, and just some very basic practices like building or designing hardscapes or barriers with mulch, which is not very friendly to ticks, can create a tick-safe zone in our homes and reduce our risk of exposure that way. Another aspect of the practices that we can utilize are just behavioral. If you're not at home and you're not living in that environment that you can control and nicely manicure if you choose to, but you'd rather go out for a hike, you can just do simple behaviors, things as simple as staying in the center of the trail. So the image here of the trail, you can see down the center that it looks very much like the kind of like a lawn space. It's been a well cared for trail, and that the ticks, if you were to look for ticks in this habitat, you would find the ticks on the sides in the brush and not down the middle. So a simple behavior one could do is just to make sure that you stay to the inside of the trail and avoid contact with these surfaces where the ticks might be. Another avoidance aspect is you can just take into account the geographical nature of tick distributions. So here's two different tick species that we have common here in the Northeast, the black-legged tick and the Lone Star tick. But you can see that there are parts of the country, and I don't show all the different species of human-biting ticks here, but there are parts of the country where these ticks are more prevalent than others. So there's this Ohio River Valley area where black-legged ticks have been historically less frequent, although they are expanding their range. Nonetheless, there are geographical considerations in terms of avoidance of ticks. In addition to geographical avoidance strategies, one can think about temporal avoidance strategies. So it turns out that the distribution of ticks is not uniform throughout the year. And now I'm thinking for the moment just about black-legged ticks, or the ones that transmit Lyme disease. Now, as I sit here in Amherst, we got a storm last night. We got probably 5 or 6 inches of snow and a nice crusty layer of ice on top of that. It's safe to say that today would probably be a pretty safe day to be outdoors in terms of ticks. So ticks don't function well. Right now they're hunkered down in the leaf litter below that snow. But for the most part, the rest of the year, they can be active, but there are clearly periods of greater activity as shown here. So this is just a week by week. This data is actually ticks that we receive in our laboratory. These are ticks that have actually bitten people, been sent to us for tick evaluation and tick testing. And you can see there's this sort of bimodal distribution of the gold bars. Those are when the adult ticks are active, here in the spring, again in the fall. And then nymphal ticks that are active sort of later into the spring, into the summer. And then in the months of August and September, you'll notice there aren't a lot of ticks altogether, not a lot of ticks to speak of, because most of the ticks at that time are larval ticks and tend to go undetected when they bite humans. They also are ticks that pose very little risk of disease transmission because ticks are born as larvae without infection with the Borrelia agent. So what I'm showing you here is that if you look over the course of a year, you see that the distribution of ticks is not uniform. And one of the things that can be done is you can plan your outdoor activities. You may elect to take your vacation, if it's a tick temperate zone in a site when the ticks are less active, or at least when you're going into tick active areas to know what time of year it is and what type of ticks you could look for. A major difference between the gold bars and the blue bars is the gold bars are the adult ticks and they're quite large compared to the nymphal ticks and the blue bars, which are relatively small and have a greater tendency to go unnoticed. So both for avoidance and detection, it's useful to know what ticks are active and when they're active. This slide is similar to the last one, and it just sort of shows over a 2-year period the differences between ticks as they've been submitted from Franklin County and Barnstable. And it emphasizes that Franklin County is in the western part of Massachusetts. Barnstable County is basically Cape Cod in Massachusetts. And there are different times when we see the activity periods start and end in different parts of the state. So it's also useful to have that very localized information. Okay, so moving past the idea of trying to reduce sources of ticks, avoid the ticks as they occur in the environment by just simple behaviors that aren't particularly invasive, we can also make efforts to protect ourselves personally. And the first one that I would mention is just by your choice of clothing. So this is not a fashion statement. This is a strategy of tucking one's pant legs into their boots or blousing their pant legs into their socks. And it plays right into the behavior of ticks, which is they jump onto their host low, and then they have a tendency to crawl upward. And if the pant leg was worn on the outside, the way we usually wear our pants, the ticks would come up the sock and then go up the inside of the pant leg. And then who knows where they end up attaching, but clearly they would be less likely to be detected than in this scenario where they would crawl up on the outside, and they would continue to go on the outside of the pant leg and may be detected or may actually even be brushed off just through the activities that someone performs during the day. But if they were under the clothing, that's much less likely to happen. Another wise choice that this individual has chosen is they're wearing light-colored clothes. And some people mistakenly think that ticks are somehow attracted to different clothing. It's probably not the case. It's just that the light-colored clothing allows for the detection of the dark-colored ticks against that light background. So it's just another way to facilitate the process of recognizing and removing ticks. Yeah, so personal protections, very simple personal protections, other than the possible circumstance of people wondering, but if everybody does it, we wouldn't have that case of people wondering why you have your pants tucked in. There's really not much risk involved here, and it can be a relatively easy thing to do. Another thing that to think about in this slide is that long pants, long shirts generally are more protective in that anything you can do to keep the ticks on the outside of your clothing as opposed to the inside of your clothing, by the same notion that you tuck your pants in, you're probably benefiting more from having long pants and long sleeve shirts where it's practical, depending on the weather, of course. Okay, so going beyond the simplest of strategies, we can start to think about chemical contributions or chemical products that can be utilized to reduce the number of ticks that bite us. And the first one that comes to mind is DEET. And I'll emphasize that for people that sometimes get confused about this, although the name sounds similar, DEET, diethyl M-toluamide, is not the same as DDT. We know the story of DDT, which is no longer legal to use in this country, but DEET is a very, very different compound, and the fact that, other than the fact that they both start with D, they're not the same thing. So DEET is categorized as a repellent, and the history of DEET goes back to early World War II, I think 1942. It was developed, and if I'm not mistaken, it was initially developed by the USDA. So you may know that as much as we are bothered by insects and ticks, insects pose huge agricultural challenge because some large percentage of all the crops that we grow are consumed by insects before they get a chance to be consumed by us. So a focus on acaricides and repellents has been driven in no small part due to agricultural concerns. So DEET was developed in the early 40s. It was tested against thousands of other compounds. There were actually some compounds that proved to be more effective at repelling insects, but they didn't have the safety profile of DEET. Some of those compounds, other compounds, also had greater longevity. In other words, they provided protection for a longer period of time. But DEET was sort of selected because it was the best balance of sort of high levels of protection, in particular against Aedes mosquitoes, Aedes aegypti, the yellow fever mosquito, and didn't have a particularly outstanding safety profile. It didn't cause problems, didn't cause irritation or blistering or that kind of things like some of the more harsh chemicals that were tested at the time. You can find DEET. It's probably familiar to most of you. You can find DEET in a number of different products. The products differ basically in the formulation in terms of the percentage of DEET. You can find DEET from just a fraction of a percent up to nearly 100% or even 100%. Every indication for the effectiveness against ticks is that the best DEET available is somewhere in the 20 to 30%. That more DEET than that, you're probably just providing more exposure than you really need to worry about. And maybe anything less than that, it either is less effective at repelling and or it doesn't last as long. So a downside of DEET, whether protecting against mosquitoes or tick bites, is that its effective protection time is probably in the number of hours. Against ticks, maybe a couple of hours. Against mosquitoes, maybe slightly longer. But it's a product that needs to be reapplied as needed. Now, again, if you couple this with things I've said before, where you're incorporating temporal concerns and geographic concerns, if you're going to the beach where there's not going to be a lot of mosquitoes or ticks, you may want to refrain from using the DEET if you're going to be staying out of the grassy edges around the outside, and know that you just need to use your repellents at a time when they're most needed, a time and place when they're most needed. So just a word about how DEET works. We should know that the recognition character, so DEET was developed to control or to repel mosquitoes. At the time that DEET was developed in the United States, ticks weren't the same level of threat that mosquitoes were. And it's important to know that mosquitoes recognize us in a slightly different way than we recognize each other. They recognize us by profiles of gases that we give off, like CO2, our body heat, and then certain odors that are associated with the human body or mammal bodies, which are the cues that the mosquitoes use to recognize us. So when DEET was first developed, and to a certain extent today, there's some controversy about its exact action, but it's clear that one of the things that DEET does is it masks this way that mosquitoes recognize us. So it protects, it sort of covers up some of these cues, like the body odors, that the mosquitoes would use to recognize us. And in doing so, it prevents mosquitoes from honing in on us and then attaching to us. The reason that's worth talking about is ticks have very different behaviors in terms of how they find us. So where a mosquito can fly, in some cases fly tens of meters across a field, for example, to find a mammal host or a human host, ticks don't fly, they don't crawl very far, they don't drop from trees, they don't jump. And so they have very different behaviors. And so the notion of blocking their recognition patterns isn't as effective. But fortunately for us, DEET has a secondary effect both on mosquitoes and ticks, and that even after ticks and mosquitoes have attached, there's clearly some repellency that the ticks and the mosquitoes will avoid the areas of the skin that have been treated with DEET. So I just want to have this little video to show that sort of emphasizes the difference in the types of behaviors So mosquitoes are out flying around looking for us. Ticks don't do a lot. They don't fly at all. They don't even do a lot of crawling. They probably only crawl a few meters in their whole life. And most of that crawling involves what she's doing, this tick is doing here, crawling out to the edge of a branch and then engaging in what's called a questing behavior. And when someone comes by and they have an exposed exposed leg, no long pants, no bloused boots, no DDT, no acaricidal treatment, then the tick attaches. And then this is the thing that frightens us all, is she will attach herself and then start this feeding process. And in the feeding process, will introduce pathogens, or may introduce pathogens as a matter of the course of that bite. So a repellent which is aimed at masking our presence or masking our image as seen by mosquitoes is not going to be particularly useful at masking our image to ticks, because if you notice in that video, the tick didn't have to see the female walk by, the person walk by. The tick was just, it crawled to the end of a branch, and it does so in a way that it hopes there's going to be hosts wandering by. So in that regard, that aspect of the DEET is not quite so useful. Very often, other compounds get sort of grouped in with repellents. So I'm going to tell you about permethrin, which is the one that pretty much is universally acclaimed as probably the superior approach to DEET. Most people, I think, would actually argue that you should use DEET in combination with pyrimethamine, permethrin. The distinction is that permethrin is not truly, not so much a repellent, but truly an acaricide. The action of permethrin, and I've just shown one of the many products. In fact, if you go to trying not to use a brand name, but like a farm store where they sell, for example, horse supplies, you'll find in the aisles for bug dopes or horse dopes, you'll find many different products that include permethrin as an insecticide or acaricide. And what these do is they're contact killers. They kill the insects that come in contact with them through they absorb the material through their feet. They're something like 2,000 times more deadly to arthropods than they are to humans. And so they have this wonderful aspect of being very deadly to arthropods and relatively safe for us, or quite safe for us. Are they completely safe? No. Is any kind of chemistry completely safe? No. But DEET, like permethrin, have been in use for decades. And so one of the advantages of that longevity is that millions, literally millions and millions, if not hundreds of millions of people have utilized them. And the number of instances of serious illness associated with the risk of those chemical exposures is drastically outweighed by the success of avoiding ticks and tick bites. This is an image, just a couple of statistics to show you. Again, this is by Tom Mather's group out of University of Rhode Island, showing you this very interesting study that was done where they actually placed ticks. So these are specific pathogen-free. These are ticks that they knew were not infected. But they placed them on people that had been either wearing treated clothing or untreated clothing. And what they showed was that people, for example, wearing permethrin-treated socks and shoes had 74 times less likelihood of getting a tick bite. That's an important thing to remember, because very often, even people that know about permethrin and or utilize it, they'll treat a pair of pants, favorite pair of hiking pants, but they'll forget about their shoes or their socks, which are usually the first place that ticks jump onto. And so it's clear that treating the shoes can be very effective. And while it's not 100% effective, it clearly has a significant impact. And much of it has to do with, whether it's used in conjunction with other practices like tucking the pant legs in and that kind of thing. Also, I should mention that permethrin can be purchased as a product that you can apply to your own clothing at home. The manufacturer's instructions vary a little bit, but basically you lay your clothes out, you spray them, you let it dry, and then it lasts for several washes after that. You can also send clothing out to commercial operations that will treat the clothing for you. And you can also just buy the clothing already impregnated with the acaricide, with the permethrin. In this study, they found that there really wasn't a difference between the home applications when done properly and the commercially supplied products. All right, so going back to that notion of the castle and the moat, there are all these layers that we could talk about, some of which are further from our person, all the way down to the personal stuff where we're actually applying chemicals to our own body to protect ourselves from tick bites. And I think it's important to recognize that multifactorial approach, and to appreciate that that in coming up with a strategy to protect yourself or the people in your charge, you can figure out which of those combinations of strategies work best. We do a fair amount of outreach here in the lab, and one of the things we'd like to be able to do for groups is to help them to figure out what is a strategy of best practices that would work best for their group, and to evaluate those as needed. So we would welcome your input. We have a staff here of folks that could answer those kinds of questions, or provide some additional resources to help you to evaluate those things. But I want to sort of close here by just saying that everything I've mentioned up to this point is about protecting oneself from exposures to ticks. But it's fundamentally important to know that even if all those things fail, so even if the tick avoidance and the source reduction and the personal protection measures have failed and you've acquired a tick bite, there's still things that can be done to reduce the risk of serious illness. And specifically, there's the fact that the tick feeding process is not, it's a process that takes place over several days, as these pictures show. And I'm sorry for showing these without warning you right around lunchtime, but the fact is that ticks remain attached to the skin for a long time, and if you remove them sooner, and the numbers vary, but certainly within the first 24 hours, you can greatly reduce the incidence of tick-borne diseases, because the ticks have to feed for usually at least 24 hours to transmit things like Lyme disease. Now, for some pathogens, that might be slightly shorter, but nonetheless, the sooner you can remove ticks, irregardless of the species of pathogen, you can have tremendous impact on reducing your risks, even after the tick has bitten you. One of the things we emphasize to people is to not make tick removal complicated. Don't use matches or nail polishes or Vaseline, or dish soap is another one I've heard about. The best thing you can do is just get the tick off as quickly as you can. And the notion that if you're not careful and you break off pieces of the tick and then you'll create a bigger problem is just not true. Once the tick is dead, that tick no longer poses risk of transmitting Lyme disease to you. If it's already done it, then it's done it. But if it hasn't done it, it's not going to do so after you break off the tick. So any of these other approaches basically end up just leaving the tick for a longer period of time. So in fact, maybe nail polish will make the tick back out because they don't like nail polish for whatever reason. But it's going to take some time, and in the meantime, you're increasing the risk of transmission of pathogens. So none of these approaches is recommended. The best thing is to pull them off as quickly as you can. There are a number of different products out there to do this. Some of these I think are more preferable than others. We kind of like this tool that has a fine pair of forceps and a scoop at the other end. There are different types of scooping devices and twisting devices. I'm not crazy about the twisting idea, but frankly, anything that gets the tick off and makes it less complicated is going to greatly increase your risk of or your possibility of a favorable outcome. And the process is relatively straightforward. You take the tool, like the forceps I showed in the previous picture, you just grip the tick close down to the skin, and lift it off and get it out as quickly as you can. This is just emphasizing and putting to rest that fallacy that if you don't remove the tick properly, if a small piece is left behind, then that poses risk of transmission of disease. And the fact is that dead ticks, because the feeding process has to be active in order for transmission to take place, dead ticks don't transmit pathogens. There's a little image cartoon that informs that a little bit. So here's what happens when a tick attaches. She'll auger herself into the skin, cement herself in place, and then over the course of that 7 to 10 day period for adult ticks, she actually is spitting and sucking things out of the it's called a feeding lesion, and it's not all aspects of this process involve transmission of pathogens. It's only after 48 hours in particular cues and maybe even some host factors that facilitate the movement of pathogens from that tick into the site of the feeding lesion and or vice versa. And so it's important to know that that's not simply a process like a needle injection or a syringe kind of scenario. So it's important to remember that every tick is infected. In fact, 20 to 30% or only 20 to 50% are infected with the Lyme disease pathogen, lesser numbers for some of these other pathogens. And so it's fundamentally important to know that even if you fail to keep all the ticks off you, even if the tick is fed on you and fed for a sufficient period of time, there's a chance that that tick isn't the one that's infected. And for that reason, we think it's very important to know what the species of tick is, to know how long it's fed, and to evaluate the risk of individual ticks. And in future webinars, I'll tell you more about how you can have that tick evaluated. So we have a very good service that allows people to test their ticks. I'll tell you why I think that's extremely useful and can be a tremendous aid in making those evaluations. Even after the tick is bitten, even after everything else has failed, one can still make an assessment of the importance of that tick. And if you want to learn more about it, you can just go to our tick report site, and you can learn more about the service we provide, including how and why it is that we evaluate the feeding time of ticks. I'm just going to go through these very quickly because I want to get to this last slide, which tells you about the next webinar. It'll be a month from today. Again, on March 13th, it's at noon. I'm seeing now, and I apologize, I'm new to the webinar scene, so I see now that some questions have been coming through. Let me see if I can address some of these.